Check. Integrated Math 3, this is the solutions video for lesson 5.04, Trig Graphs. This is the one that we did in class. You're only going to do a small part of this assignment. You're only responsible for what I'm actually doing, what I did in class, which is what I'm going to do on this video. So what we're going to do is we're going to plot some of these, and we're just going to use Desmos to see what they look like. So we're going to plot sine x, we're going to plot 2 sine x, and we're going to plot negative 2 sine x. So we're going to do all those. We can use this entire space to do those. We're going to do them on the same graph so that you can see how they compare to one another. So the way I'm drawing this graph is, let's first of all talk about what we're doing in graphing is we're taking the unit circle and we're going to cut it. Imagine it's just a big string going around there. We're going to cut it right here, and we're going to stretch it out from left to right. So this is going to be furthest on the left. Then we're going to go around to here. That's going to be moving to the right. Then we're going to come around to here. That's going to be moving further to the right. Then down to here, further to the right. And finally, we're going to get back to 2 pi. That's going to be way out here. And you can even go beyond 2 pi. Remember, you can keep going around and around the unit circle. So let's start, and let's go ahead. And what I'm going to do is every pi over 2 is going to be, I'm going to measure it out. I'm just going to make my scale on this piece of paper 2 centimeters. So right here, we're going to start with 0. And 2 centimeters is going to be right here. It's going to be pi over 2. So it's 90, if you like to talk about degrees, it's going to be 90 degrees. But when the graphing, we generally use the radians, okay? So it's going to be pi over 2. Okay. Now we're going to come around to this side of the circle, which is pi. So we've gone around like this. So now we're going to go another 2 centimeters and call that pi. And then another 2 centimeters, we're going to go down here to the bottom. That's going to be 3 pi over 2. And finally, we're going to get back to where we started right here, which is 2 pi, and that's another 2 centimeters. So you can see we basically took the unit circle, we cut it, and now we're just kind of stretching it out onto a graph. Okay, and if you wanted to continue going on, we could go, I'll just make a mark every 2 centimeters here. We can go from 2 pi up here, which would be, that's 4 pi over 2 plus another pi over 2 is 5 pi over 2. And over here it would come around, it would be 6 pi over 2. Every time you go a quarter of the way around the circle, it's pi over 2. So 6 pi over 2, which equals 3 pi. And then finally, this would be another pi over 2. That would be 7 pi over 2. So you just keep adding pi over 2, but when you can reduce the fraction, you reduce the fraction. Okay, so there we go. Now, let's draw a line here. That's going to be, okay, so there we go. So there's our graph. So what we're going to do is we're going to go to Desmos. And let's go ahead and do. Okay, we're going to first just go ahead and plot sine of theta. But on Desmos, we're going to call theta x. It doesn't really matter, but we're going to call it sine of x. And there it is. So let me zoom in just a little bit here. Now, one thing you're going to want to do is, you see how we have numbers down here. We don't have the radians, the pi, pi over 2, 2 pi, so forth. So the way you change that is you come up here, and you go to the x-axis, and you're going to change the step. You don't need to change this over here. Just change the step, and we're going to change it. I'm going to go into the keyboard of Desmos there, and I'm going to click pi, and then on my keyboard, my computer keyboard, I'm going to hit slash, and then 2. So we're doing pi over 2. So that's 90-degree steps, okay? And that's all we need to do. And now we close that. Do that. And now you see, let's zoom in just a little bit here. Okay. And now what you see is that at 0, let's compare this to the unit circle. At 0, the sign is 0. And remember, the second number So I'm going to be switching back and forth. The second number is always the sine in each of these pairs. So at 0, that's where we are here, the sine is 0. At pi over 2, the sine is 1. Let's go back to Desmos and confirm that. And there it is, at pi over 2, it's 1. This distance is called the amplitude. It's the height of the wave, okay? In this direction it's negative, but it's the same distance. It's -1. So in this direction it's +1. In this direction it's -1. So we see that the sine at pi over 2, which is 90 degrees, is 1. Now when we get to pi, which is 180 degrees, then the sine is back to 0. It's 0 on the y-axis. So let's confirm that. And there it is. At pi, the sine, which is the second number, is 0. Now when we get down to 3 pi over 2, sine is going to be -1. So let's go confirm that. And there it is right there. At 3 pi over 2, the sine is -1. Then when we get back to 2 pi, that's back at the beginning, the sine is back to 0. So we come over here, and at 2 pi, the sine is again 0. So we've made one full loop around the circle. So what we're going to do is we're going to draw that here on our graph. Okay, exactly what we saw. So at 0, sine was 0. At pi over 2, let's go ahead and make a measure up and down here. And again, I just happen to use 2 centimeters. You can use something different. So 2 centimeters is going to be 1, and 2 centimeters in the other direction is going to be -1. So this is -1, and this is 1. Okay. So we said at 0, sine was 0. At pi over 2, it went up to 1. That was 90 degrees. At pi, which is back on the other side of the circle, it's back to 0. At 3 pi over 2, that's the bottom of the circle. It was at -1. And at 2 pi, it's there. So we can just sketch 0 to 2 pi. And so it's going to look like this. You have to just freehand this. Just try to do it as neatly as you can. It looks like this. Okay, and if we kept going, it would keep following that pattern, okay? So this is sine of theta. And Desmos calls it x, but we're calling it theta right here. What about 2 sine theta? What this is, this number out in front is called the amplitude of the wave. And what that means is it's the height of the wave. So 2 sine theta is going to look exactly like sine theta, except instead of it going up to 1, we're going to have to draw another line up here. I'll go ahead and measure that. It's going to go way up into the words here, but that's okay. And down here on the bottom side, it's going to go way down here. There. So this is -2, and way up here is +2. Okay? So this one is going to look just the same, except it's going to go, it's taller. The wave is taller, and it's also taller on the low end. It's going to go lower. Okay? All of these 3 points are going to stay the same. So it's going to look like, okay, and this one is 2 sine theta. So the number out in front of the sine makes the wave taller. It still crosses the x-axis at the same points, but it's a taller wave, okay? And now let's look at this one. So let's go to Desmos and let's plot these. Okay, there's sine x, and we just did 2 sine x, so we can confirm what we just saw. And there it is. You see it on the screen there, because the blue wave is taller. Okay, let me close this out. The blue wave is taller than the red wave. It goes as high as 2. Now let's put a negative sign in front, because the next one's asking us for -2 sine x. We put a negative sign and see what happened to the blue wave. It got flipped. It's exactly, all the numbers are exactly the opposite. So +2 becomes -2. 0 is still 0, because 0 is -0, right? Same thing. -2 became +2, and so forth. So now we can go on back to our graph, and we can draw that. So we're going to need to come down here to -2 right here. It's going to be the opposite of what this is. Oops, didn't switch over there. Okay, we're going to come down here. It's going to be just the opposite of this. Then 0 is still 0. Then the 2 sine theta was negative, so the negative sine theta is going to come up to positive. It's going to be whatever the opposite is, and then back to here. So it's going to look like this. Just do the best you can freehanding these sine waves. There's no way, way to really do them properly. Okay, and you know what I should have done? I should have made this like a dashed line so you could tell the difference between the other one. So let me just erase parts of this one. Okay, so the dashed line is -2 sine theta. Okay, so the key to this is amplitude. There's the word right there. The number out in front gives you amplitude. Okay, and negative sign just means it's inverted. Okay, let's move on to the next. Okay, and what I did here in class was I kind of scratched a lot of these, so you can put X's through those. What we're going to compare now is cosine of theta and sine of theta. So we've already done sine of theta, but we're going to do them both on the same graph and see what they look like, okay? So what I'm going to then do is we're going to leave the coefficients as 1, so that means the height of these is going to be just 1. So let me go ahead and draw my graph here the same way I did before. So this is going to be 1, 0, -1 for the height. Okay, so that represents 1 time around the unit circle from 0 to 2 pi. Okay, so we already did sine, so let's do it again. It starts at 0. At 90 degrees, pi over 2, it goes up to 1. At pi on the other side of the circle, the left side of the circle, it's back at 0. 3 pi over 2, it's down to -1. And at 2 pi, it's back to 0. So we already saw that up above. So let's go ahead and sketch that. And there's a sine. Now let's go on to Desmos and let's see what cosine looks like compared to sine. So we're just going to erase this, and we're going to, whoops, I'm going to go that far, sine x. Boom. There's sine x, and now we're going to do cosine x. Okay, so it's that green line. So you see they kind of follow the same form, but they're shifted over. So let's see what's going on there. So this, remember, the sine is the red one and the cosine is the green one. So let's look at the unit circle and see how they relate to each other. So we'll go on back to the camera. Okay. So at 0, the sine is 0. If we then go from here up to here so that we're now at pi over 2, the cosine becomes 0. So how do you write an equation that equates the cosine to the sine? At 0, the sine is 0, and up here, when you go up pi over 2, so theta plus pi over 2, the cosine will be 0. So you would write that as an equation like this. That cosine, whatever the cosine of theta is, so remember at 90 degrees or pi over 2 it equals 0, that's going to equal whatever the sine was plus pi over 2. So let me show you that again. You see what is the sine of a particular angle. Now you add pi over 2 to that. Now we got to be careful. It's parenthesis pi over 2. You're adding pi over 2 to the angle theta, not to the sine of theta. So we're taking the angle theta, we're adding pi over 2 to it, and taking the sine of that, and that will give us the cosine of theta. Okay, so let me show you that again in a different way. If we say, what is the sine of theta? Or excuse me, if we want to know what is the cosine of theta? Let's say theta is 0. So the cosine of 0, the cosine of theta, is 1. Okay, so how does that relate to the sine of theta? Well, if we go to sine of theta plus pi over 2, so this is theta, 0, and we're going to go plus pi over 2. And what's the sine of that? It's 1. So the cosine of theta is 1. The sine of theta plus pi over 2 is 1. So to equate the two, if you take theta, let's say it's 0, plus pi over 2, that will give you, the sine of that would be 1. that's going to be equal to the cosine of theta. So the original theta was down here, was 0. Okay, so the cosine of theta is 0. The cosine of theta plus pi over 2, excuse me, the sine of theta plus pi over 2 is also 1. So to equate those two, cosine of theta equals sine of theta plus pi over 2. Okay, so just kind of have to think about it a little bit and see what's going on there, okay? So what that means is, let's look at the cosine. The cosine is always the first digit. It starts at 1. At pi over 2, it goes to 0. So right here, we're going to start the cosine at 0. It's already at 1. When you get to pi over 2, the cosine comes down here. Now we can see the same pattern starting to develop. When you get down to pi, the cosine is going to be -1. You're going back 1 on the unit circle. Then when you get to here, it's going to go up to 0. That's at the bottom of the circle. And then here, it's going to be back to 1 again. So if we sketch that, it's going to look like this. And let me draw dashed lines so that we can tell them apart. Okay, so this is sine of theta. This is cosine of theta. All right. So again, let me say it one more time. What's the equation that would relate the cosine of theta to a sine? Well, this is the cosine of theta. It's 1. This is the sine of theta plus pi over 2 is also 1. So the cosine of theta, again, that's the angle right here, which is 0. The cosine of theta, which is 1, equals the sine of theta plus pi over 2, which is also 1. So to equate the two, you use this equation right here. Okay? Now, remember what happened when we added something to an angle there when we did, remember the transformation? Remember how we said that this one is backwards? It's opposite. It's a plus pi over 2. That means you go backwards. So if you start at the sine curve, this is the sine, and you go backwards pi over 2, that will get you to the cosine. Okay, again, this solid line is sine, the dashed line is cosine. So the sine of theta plus pi over 2, that's right here, is going to, and the of theta, and then you add pi over 2, you're going to move it back. Okay, the plus sign makes it move to the left. And so that gets you to here. So you're at the equivalent point of the, here and here, the equivalent point of the cosine and sine. They're both at their highest point, right? You could have done the same thing down here. Okay, now what we're going to do is we're going to put a coefficient in front of the angle theta. Before we put the coefficient out in front of sine, that changed the amplitude. The next thing we did was we added something to theta, and that shifted it right or left if you add something to theta. Now we're going to multiply theta. Okay, and this is called the frequency. So let's go ahead and draw that. All the coefficients in front of the sines here are going to be 1, so we don't have to, our height doesn't have to be any higher than 1 here. Okay, so mark this off. Pi over 2, that's 90 degrees. Pi, that's 180. 3 pi over 2, 270, and 2 pi, that's 360 degrees, okay? All right, so let's do a sine first. So sine, we're going to do this, and we're going to do this, okay? And we don't need to do this. Once you see what 2 theta does, 4 theta will do the same. What we are going to do instead is just another regular sine, so we can compare it to just a regular sine, okay? So we're going to do these 3 right here. All right, so let's do the sine. We know what that's going to look like. It's going to be 1 here, 0, -1 here, 0. So there you go. Okay, not a very nice curve, but they aren't always nice curves. I'll have to live with that. Okay, so let's go and see what 2 sine 2 theta does. Let's go check that out on Desmos. And then it's 2x. Okay, so it's the green line. So what is the green line doing, and how do we interpret what that 2 means? Well, let's first of all realize what a cycle is. A cycle means the wave starts at a point, and when it gets back to that same point in the same direction, that's one cycle. So we're starting right on the x-axis here, okay? We go up, we come down. Now we're back to the x-axis, but it's not going in the same direction. This one is going up, this one is going down. So we have to go down and then come back up in the same direction. Right there at 2 pi, that's one cycle of the wave. In other words, it's one complete motion of the wave. If you just do from here to here, you've only done the top part of the wave, you didn't do the bottom part. So one cycle, it's going to start here, it's going to go up and come down, go down and come back up, and right to where it started on the x-axis. So that's a cycle. So what sine of 2x is saying, what the number in front of the x is saying is, there's an implied 1 there. I can go ahead and write it so you can see it there. There's a 1x there, okay, as opposed to a 2x. What that means is that's how many cycles are going to occur between 0 and 2 pi. So we have one cycle between 0 and 2 pi. It went exactly one cycle. Up, down, down, back up again at 2 pi. So let's look at what 2x does. Let's turn this one off and turn on the 2x. Now look at this. You start at 0, you come up, you come down, and you come back up, and at pi you're at one cycle. You come up, you come down, and you come back up. At 2 pi you're at 2 cycles. So the way to interpret these numbers in front of the x is it's telling you how many cycles is the wave going to make between 0 and 2 pi. So again, 2x is going to be up, down, up, that's one cycle at pi, up, down, up, that's 2 cycles at 2 pi. So sine 2x is going to do 2 full cycles between 0 and 2 pi. Sine of x is just going to do 1 cycle between 0 and 2 pi. Okay. So what's sine of 1/2 x going to do? Here we go. I had to fix the 1/2 x. So look what happens. It means it's going to do a half a cycle between 0 and 2 pi. So it's the blue line. It's going to come up and come down at 2 pi. That means it only did half a cycle. It only did the top half of the cycle. It doesn't even get to the second half, the bottom half of the cycle. So it only did a half a cycle between 0 and 2 pi. So again, the way to interpret these numbers in front of the x or in front of the theta is how many cycles will the wave make between 0 and 2 pi. Okay, so let's go back to our camera. All right, so we've already got pi. So this, or excuse me, sine of 1x. I'm going to call it 1x just to emphasize that coefficient in front of the x, and it's really in front of the theta. We're calling it theta here. Okay, now we're going to do sine of 2 theta. So what's that going to do? It's going to be 2 cycles. So we're going to start here at over. I'm going to draw a dashed line for this one. It's going to come down through pi over 2 and come back up at pi. So that's 1 cycle right there. Now it's got to do a second cycle. So it's going to come up here. I should have curved that down a little quicker. And then it's going to come down to 1 and then come back up to here. So it did 1 cycle, 2 cycles between 0 and 2 pi. That's what this one did. So let's mark that one. This one is sine of 2 theta. Okay, and the last one is the sine of 1/2. I'll draw with x's. So it's going to be x, x, x. So it just does half a cycle. It just does the top half of the cycle. So this is 1/2 theta. Okay, and that's what we saw over on Desmos. Once again, there it is. Okay, that's what you just drew. Okay, so far we've dealt with a coefficient in front of the sine, that was amplitude. We've dealt with a coefficient in front of the angle, that's frequency. So that's called the change in frequency. It's how many times it cycles between 0 and 2 pi. The other thing we did was we added something to theta, and we saw how that shifted, the cosine shifted. So now what we're going to do is we're going to do a couple of transforms, and we're going to actually do 2 things here. We're going to draw this twice. We're going to do sine of theta plus 2, and we're going to do sine of theta plus 2. So what this one is saying is you add theta plus 2, you get that number, and then you take the sine of it. This one is saying you take the sine of theta, you get that number, and then you add 2 to that. Those are two different things. So let's see how those differ. So I'm going to draw the same kind of graph that I did before. Okay, this is 1, 0, and negative 1. Okay, actually, I'm going to tell you what. I'm going to make this 2 and this negative 2, and I'm going to put the 1. I'm going to do that because I can see that we're going to have some heights here. So we're going to call this one 1, and we're going to call this one negative 1. Okay, there you go. All right, so let's see what sine of theta plus 2 looks like. We already know what sine looks like. We're pretty comfortable with that. It goes up to 1, comes back down through pi, and goes back up to 2 pi, and its height is 1. So let's see what this looks like. So we're going to go to Desmos. And let's go ahead and X out everything here. And let's see. Okay. So, and let's compare that to just sine x. Okay. So what it did was, we know what this is going to do. This is sine x right here. It's going to shift it back to, now since our x-axis is in all these radians, is kind of weird numbers, pi over 2 and pi, it's hard to say that that's really 2, but if you just trust me, going from here back to the top of the black wave is 2. So remember, the plus 2 shifts in the opposite direction laterally or sideways or horizontally. It goes from here, and then plus 2 goes back to there. So just trust me when I say that is plus 2. Now let's see what this is. Look at the difference between this first one and this one. It's sine. Let me put the parenthesis in first. And now we're going to add the 2. So we take the sine of x and then we add the 2. Now what you can see, that does what you would expect it to do. It shifted the red curve up 2. So with the top of this red curve is at 1, the top of the blue curve is at 3. So at 1 plus 2 is 3. So it shifted it up. So this one's kind of obvious. This one is simply saying that it shifted it to the left. So again, what's this mean? It means you take the angle x or theta and you add 2 to it, and then you take the sine of that number. This one says you take the angle x or theta, you take the sine of that angle, and then once you have the sine, then you take the number. You do it in different order, okay? So let's go ahead and draw that. So sine of theta, we know what that is. We're going to start here. We're going to go up to 1, and then down to pi, and then down to negative 1, and then back to here. So this is sine. So we've drawn that about 3 times already. I'm not drawing it any better than I was, probably worse. Okay, so this is sine of x or theta. Again, it doesn't matter which variable you use. Theta is usually used for angles, and that way people know that you're talking about an angle. So that x could be a variable for anything. Okay, all right. Next is going to be sine of theta plus 2. So that's going to shift it to the left 2 places, okay? So let's kind of take a look at where Desmos put that one. So that's this black line. So it looks like it crosses a little, it peaks right up here, and it crosses a little bit below 1 there. So I'm going to try to draw that. So it peaks right here, it crosses about right there. But then other than that, it's going to look exactly like this. So if I do this right, it's going to come down. It's still going to have a height of 1. I want to go back and look at Desmos. That's a little hard to do, that one. Okay, it's going to come down. The bottom's going to be over here to the right of where the red one is, where the sine x is. So it's going to come down. Get rid of this. And it's going to bottom right there. And then let's go see what the rest of it does. Okay, and then it comes up. Comes up right about here. And whoops, it shouldn't go higher than 1. It should be right there. Okay, so we're going to say that's about what it is. And this is going to be sine of theta plus 2 in parentheses. So theta plus 2, and then you take the sine of whatever that adds up to be, okay? And finally, the sine of 2 theta is easy. This is 1, so you got to come up to 3 up here. And you're going to start at 2. 0 plus 2 is 2. 1 plus 2 is 3. 0 plus 2 is back to 2 again. It just shifts the entire way. It's like it puts it up on a platform. Down here you have 2 minus 2 is 0. And then finally you're back to here. So this one's going to look just like sine x, except it's set up on top of a table. It's higher. So it should look exactly like the sine x, and if my drawing were better, it would have. And so this is going to be sine of theta, and then you add 2. You put it up on top of a platform that's 2 feet high. That's the way you can think of that, okay? All right, I'm not going to do this one. Well, yeah, I can. So this one is simply going to be, I think what I did in class was this, sine of theta in parentheses, and then you drop it down 2. So you're going to start down here at -2, you're going to come up to 0, you're going to come back down to, did I do that right? No, I didn't. Not going to come up to 0. You're going to come up to -1, you're going to come back down to 0, you're going to go down to -3, put -3 down there. You're going to come down to -3, and you're going to go back up to -2. So -2 is effectively your 0, okay? So it's going to look like this. And that's sine of theta. Take the sine of theta and then subtract 2 from it. So it looks exactly like sine of theta, except it's 2 lower. So this one is -2, and this one is supposed to be, it doesn't look like it, +2. This one's 2 higher, and this one's 2 lower. These two are separated, okay? All right, that's all I did in class. I just wanted you to see how these graphs kind of work, what they look like. Believe me, you'll see these a lot in trigonometry and calculus, so you want to get comfortable with trigonometry. It takes a little getting used to, but it's not that hard, okay? So again, if you're going on to further math, be sure you understand what went on here. Otherwise, just get the assignment down and turned in, okay? That's all I have for this lesson, so I'll see you in class on Monday. Have a good day.